Thanks for tuning in. This is Kisembo Academy. In this tutorial, we shall look at the circumference of a circle, we shall look at the area of a circle, we shall look at the perimeter, and other basic calculations around the circle. We said that circumference of a circle is simply the distance moved around the circle, and we'll go straight into calculations. Find the radius of a circle whose circumference is 44 centimeters. Now, there's formula for circumference of a circle. Circumference is equal to pi d, or circumference is equal to 2 pi r. Of course, these two times r is equivalent to d, because we know that the distance or the diameter of a circle is equivalent to 2 times radius. So when we replace this d with 2r, it becomes 2 pi r. So to find the radius of a circle whose circumference is 44 centimeters, we simply quote that formula that the circumference of a circle is given by 2 pi r, and we know that it's going to be 2 times pi. Pi is 3.14 or 22 over 7 times the radius. Now they are asking us to find the radius of the circle whose circumference is 44 centimeters. So the circumference is 44. Then we get our value of r. The diameter of a circle is 21 centimeters. What is the circumference? So we know that the formula for circumference, C is equal to pi d, or 2 pi r. So they want the circumference of a circle. So our value of pi is 22 over 7, or 3.14. Multiply that by the diameter. They are telling us the diameter of the circle is 21 centimeters. So it means that by 7 once, by 7 thrice, 3 times 22 is 66 centimeters. So the circumference of that circle is 66 centimeters. Chimba moves around the circle of diameter 56 centimeters 50 times. What distance does he move in meters? So we are being told that Chimba is going to move around the circle 50 times. So this is the circle they are talking about. Chimba moves around this circle whose diameter is 56 centimeters. The diameter is 56 centimeters. But he moves around it 50 times. So it means he's going to move around this circle circumference 50 times. So what distance does he move in meters? So what we do here, we are going to first find the circumference of this circle. After finding the circumference of that circle, then if we are to find the distance this guy moves, it means you're supposed to multiply that circumference we get by 50 times, because he moves around the circle 50 times, and that will be the answer we will get. So since to get the circumference, we know that circumference of a circle is going to be equal to pi d. Remember, this 56 is diameter, so this distance is from here to there. So it's pi d, which is going to be 22 over 7 times the diameter, which is 56, and it is in centimeters. So our answer here is the circumference of this circle is 176 centimeters. So 176 centimeters is the distance that is moved around this circle in one revolution or one round. But Chimba moves around the circle 50 times. So to find the distance he moved, it means that we're supposed to multiply this by 50. So to get the total distance moved when he moves around 50 times, we shall get 8,800 centimeters. But then the question requires us to find the distance he moves in meters. So it means we're supposed to convert this to meters. And when we convert this to meters, we divide this by 100, and we shall end up getting 88 meters. Next question. Martha has to run a race of 440 meters around a circular field of radius 35 meters. So this is the circular field, and it is having a radius of 35 meters. Martha has to run around this field. How many times does she go around the field? So she's running this distance, but around this field, but we do not know how many times she runs around it. So what we do here, we need to first find the distance that how long will he run if she runs around it once? Then if we know how long the distance is when she goes around it once, then we will be able to find how many times she will be able to run around it when we in at a race that is that much. So finding how long the distance around the field is means you're supposed to find the circumference of this circle, or the circumference of the field. And we said that circumference of a field is going to be, in this case we can say pi d or 2 pi r, but since we have radius, let's use 2 pi r. That's going to be 2 times pi, which is 22/7, times the radius of the field, which is 35. And then we shall end up with our answer. The distance around the field is 220 meters, but Martha runs a race of 440 meters. So for us to be able to know how many times she goes around this field means you're going to get the total distance moved around in this distance. The total distance she runs, divide that by the distance moved around in one field. Or we can do it simply like this, that when he runs around one time, the distance he's supposed to cover is 220 meters. If he moves around, she's to move at 440 meters, how many times will she have moved? So we do not know how many times. We call that x, and then there we cross multiply. When we cross multiply, x times 220 is going to give us 220. X is giving us 440 times 1, which is 440. When you divide both sides by 220, we shall end up with x giving us 2 times. So he has to move around 2 times. Now let's try and find the perimeter of these shapes. Now before, we've been doing perimeter of a circle, or call it the circumference of a circle, and we said that circumference of a circle is pi d, or it is 2 pi r, where r stands for the radius and d stands for diameter. Pi is simply a constant, which is equivalent to 3.14 or 22/7. Now when we are trying to find the circumference of a circle, this pi d actually represents the entire circumference, the arc. When I move from here, I go around the circle up to that point. That is the distance that is being represented by this formula pi d, or 2 pi r. Now if we are being asked to find the perimeter of these following shapes, you realize that these shapes are not full circles. Let's look at this one. This is a full circle. For me to find the perimeter of this circle, I'll say circumference of this is going to be equal to 2 pi r, which is going to be 2 times 22/7 times the radius, which is 7. And the perimeter here is 44 centimeters. And so it means that this 44 centimeters is the distance moved around the whole circle, or the curved part of the circle. Now when it comes to finding the perimeter of this shape, first of all, this is a quarter of a circle because of that 90 degrees. So it means that the circumference of this circumference is going to be equal to a quarter of 2 pi r. A quarter of 2 pi r. But now this a quarter of 2 pi r is the distance that is covering a quarter of this curved surface. It means that it is this a quarter 2 pi r is representing the distance from that point up to that part. Only excluding this, excluding that. So if the circumference, or the perimeter around this whole object is going to be a quarter of 2 pi r, which is the distance from here to there, then if we are to find the remaining part, it means it's going to be plus that plus that. This is the radius, that's the radius. So it's going to be a quarter 2 pi r plus the radius plus radius. So it continues. It's going to be a quarter times 2 times 22/7 times the radius, which is 7, plus the radius, which is r, and r, which is plus 7 plus 7. And of course the answer we shall get there is 11 plus 7 plus 7, because the same happens to this. We shall calculate this right here. This circle, if you are to find the perimeter of this circle, it means that we are going to find the distance of that curved surface, then plus the distance from here to here. This is the diameter of the circle, which is 7 plus 7. This is the whole of this is 14. So this is going to be, this is half of a circle. So it's going to be a half of the circumference of the curved surface. A half times 2 pi r. Now a half times 2 pi r accounts for half of the curved surface plus the diameter. That is plus the diameter to find the distance around the whole, which is the perimeter. So it's going to be a half times 2 times 22 over 7 times radius, which is 7, plus the diameter, which is 14. And you will area of a circle. Now the formula for area of a circle is pi r squared, as simple as that. And let's look at some of these examples here. We have a full circle here and we are required to find the area. The area of this circle, this being a full circle, area is going to be pi r squared. We said that pi is a constant which is equivalent to 22 over 7 of 3.14 times r, which is 7 times 7. When we cancel both, we find our answer 22 times 7, giving us 154 centimeters squared. That's the area of this circle. Let's get to this circle. Find the area of that. We recognize that that is 3/4 of a circle, because a quarter of it is eaten away. So it means that to find the area of this circle is going to be 3/4 of the whole area. The 3/4 times the formula to get the area of that. So area of this is going to be equal to 3/4 times pi r squared, which is the area of the circle, which is going to be 3/4. Multiply that by 22 over 7 times radius, which is 7 times 7. So this cancels with that. When you compute the rest of this, you end up getting your answer as 115.5 centimeters squared as your answer. Now sometimes we are able to know that this is a quarter because this, remember, all angles at a point are equivalent to 360 degrees, and if we are having 90 degrees here, it means that the rest of this whole bit is 270, because 360 minus this 90 degrees is giving us 270 as the other part of the circle. So for us, it's to get this 3/4 as the fraction of this circle, it was as simple, it was the same as saying that the fraction, this fraction, is going to be 270, divide that by 360. And 270 divided by 360 gives you 3/4. And so, having known the fraction of this, that is how we started it off, by saying it's 3/4 of the whole circle. Looking at this other formula, this other circle, sector, to find the area of this sector, the area of that sector is going to be, if you find that this sector is just only having 30 degrees in between. So now what is 30 degrees of the whole circle? So the area is going to be 30 degrees over 360 degrees of the area of the whole circle, which is pi r squared. And that is going to be giving us 30 degrees over 360. Multiply that by pi, which is 22 over 7, times the radius, which is 7 times 7. And when you compute all that, you're bound to get 12.8 centimeters squared as the area of that sector. This brings us to the end of this tutorial. Thank you for watching. For more videos, I encourage you to subscribe to this channel and also share on other platforms. I hope you watch the next video. For Kisembo Academy, this is Arnold Rangakurami.